So let's take a look at the post lab for synthesis of alum. So we're going to focus on three main sections to your post lab: calculations, post lab questions, and conclusion. So calculations, I want you to have a whole separate section for calculations. Now it's just two calculations, but the way that your lab should be set up is you should have purpose, procedure, pre-lab questions, data and observations, and then calculations. Now, if you have procedure on the left, data and observations on the right, that's fine, but you still need to make sure you have data and observations and make sure that that section is labeled. You should have masses and you should have lots of qualitative observations. Once you have that done and you move on to calculations, make sure this is a separate section. This is actually number 8 from the post-lab questions, but I want it to be a completely separate section. You're going to have two calculations: theoretical yield and percent yield. Make sure you label each calculation. The theoretical yield is like number 6 from the pre-lab, except you're starting with your mass of aluminum, not 1.0 grams of potassium like the pre-lab. For percent yield, this is like number 7 from the pre-lab, but you're just using your data. Once you have the calculations done, then you move on to post-lab questions. So this is numbers 1 through 7. You can just number them in your lab notebook. Number 1 gives you reactants and products for every single equation, but you need to make sure you're determining the correct formulas and make sure that it is balanced and net ionic. Net ionic means you're breaking apart any strong electrolytes, so strong acids, strong bases, and soluble salts. Remember, only aqueous solutions have the potential to break apart. Number 3 of the post lab is asking for sources of error. So you are thinking about whether or not you have over or under a 100% yield. If it's over, I want you to think about why it might be over 100%. If you were under, which I have a feeling a lot of people will be, think about why it might be under 100%. Why did you not collect as much crystal as you were supposed to? You might need to look up some of the information. So like number 7 is asking about the shape of an octahedron. You might need to Google that. Just Google shape of octahedron and draw that in your lab notebook. And then conclusion, remember that is the purpose of the lab. Did you fulfill the purpose? Why or why not? And for why or why not, you need to make sure that you're giving evidence. So maybe it is percent yield, it is mass of crystals that you collected. You need to give some sort of evidence as to why or why you did not fulfill the purpose of the lab. So let's actually take a look at each of the calculations and post-lab questions in a little bit more depth. So let's take a look at the post-lab. And as we go through some of the post-lab, I'm not going to answer the questions completely for you, but I'm going to give you a lot of hints as we go through this. So first, after you have purpose, procedure, pre-lab questions, you should have data and observations. So your data and observations should be all of the masses that you use. It should be your qualitative observations, what you see. And then after data and observations, I want your calculations section next. So it goes purpose, procedure, pre-lab questions, data and observations, and then calculations. Now the calculations are actually number 8 from your post-lab questions. So if you want just to make yourself a note next to this, I already did it for you. This is a separate calculations section, and I want calculations before post-lab questions. Now in your calculations, a couple things to remember. I want your calculations labeled. So make sure you are labeling your calculations. That means that you have two calculations: theoretical yield and percent yield. So I want you to make sure that you have both of these calculations labeled. Now I gave on the hints slide your theoretical yield. Your theoretical yield was like post-lab question number 6, except you're starting with your mass of aluminum. So I'm going to set up the first part, and then you can continue with the rest. So you are starting with your mass of aluminum. If it was 1.00 grams, start with that. If it was 1.1 grams, start with that. We are going from grams of aluminum all the way to grams of alum. So if we're starting with grams of aluminum, that means that we need to use the molar mass of aluminum. 26.98 grams is 1 mole of aluminum. And then we have to look at the alum formula. So we're going to go from aluminum to alum. So we want to go from moles of Al to moles of alum, and alum is KAlSO4 2.12H2O. So for every one of these alums, there's one aluminum. So it's actually a 1-to-1 ratio. Then we just continue on, 1 mole of alum, and you figure out the molar mass. Now this is the same molar mass as what you used in the pre-lab. There's your theoretical yield. So you're going to get a certain mass. So that's theoretical. Now remember, percent yield is actual over theoretical times 100. So actual over theoretical times 100. Actual is what you collected in the lab. So if in the lab you collected 3 grams, that's your actual. Theoretical is what you just calculated. So the higher the percent yield, the better. Those are your calculations. So that's the first section in the post-lab. Then we come to the post-lab questions. So really for the post-lab questions, you're going to have 1 through 7. Now if we take a look at some of these questions, number 1, I want you to pay attention. It wants net ionic. So balanced net ionic. That means anything that is a strong electrolyte gets broken apart. So break apart strong electrolytes. Those are strong acids, strong bases, soluble salts. If we take a look at A, it actually gives us everything that we need. You just need to make sure to balance it. So aluminum reacts with KOH and water. All right, so aluminum is Al. That was solid aluminum. Reacts with KOH. That's a strong base. That gets broken apart. And water. There are your reactants. Forming potassium ions, K+. It forms this tetrahydroxoaluminate ion and hydrogen gas. Remember, anytime you have an ion, it's aqueous. So balance that. The only thing that gets broken apart here is KOH. And then to make it net ionic, make sure you cancel out spectators. I can see that there's going to be 1 spectator ion here. Then for part B, hydrogen ions from the acid. So hydrogen ions, that's just H+. Remember, anytime you have an ion, it's aqueous. React with tetrahydroxoaluminate ions. That's this Al OH4 minus. And those are aqueous. To precipitate aluminum hydroxide. So think about what that means. If it precipitates, what state of matter will it be? It's going to be a solid. So then you just need to make sure this is balanced. So figure out what you need in order to balance this. Nothing will break apart here. Everything's already broken apart for you. Then here, aluminum hydroxide reacts with additional hydrogen ions and water. So that tells you here that aluminum hydroxide, solid, reacts with additional hydrogen ions, H+, and water, H2O, to form these hydrated aluminum ions. So there's your product. Again, balance it. And then D, alum forms. So alum, we can look at the background to look at the alum formula, or look down at your calculations. There's your alum formula. Alum forms from potassium ions, K+, hydrated aluminum ions, that's this up here, sulfate ions, SO4 2-, and water. So here are all of your reactants. Here's your product. Just make sure it's balanced. So that's number 1, just looking at all of these net ionic equations. All 4 of these reactions are what you actually did in lab. Number 2, what's a synthesis reaction? So you just have to think about, what does the synthesis reaction mean? Number 3 is asking about sources of error. So why should you not expect? What could have happened that would have given you a lower percent yield? So think about sources of error. If you're not sure, or if you had over a 100% error, I want you to think about what a source of error could have been. So you're thinking about what gave you either a higher or lower than 100% yield of crystals. For number 4, solubility. How does solubility, remember solubility is when something dissolves. So how does the solubility of alum in water change with temperature? So alum crystals will dissolve in water. But I want you to think, how can you make it more soluble or less soluble? So what about temperature affects solubility? Think about it in terms of dissolving sugar in coffee. Think about how temperature would affect that. So number 5, why should you not wash the crystals with pure water? Well, I just talked about it in number 4. 6, what do your crystals look like? So that could be different for everybody. Everybody's crystals looked different. And then 7, what's the shape of an octahedron? So this you might need to look up. You might need to look up shape of an octahedron. I would recommend drawing the shape. So draw the shape of an octahedron, or draw an octahedron in your lab notebook to help you. Right? And number 8, you've already answered. So 1 through 7, there's your post-lab questions. And then your conclusion is at the very end. Conclusion is purpose. Did you fulfill it? Why or why not? So remember, what was the purpose of this lab? Did you fulfill the purpose? And maybe tell me your percent yield as evidence. So in the why or why not, you can give me your percent yield. You can say, yes, we fulfilled the purpose because we collected 75% of the crystals that we expected. Something like that. So that's your conclusion at the very end. So that is the post lab for this alum lab. You want to make sure that you have everything filled out in your lab notebook. Make sure that you've gone through and you've read this background information. You can see up here, here is the formula for alum. Here's the formula for alum. And then you can go through, make sure you read the background. You're familiar with what we did in the lab.